Good morning, Chris. Ladies and gentlemen, my name's Darryl and I'm here today to discuss the topic of trilobites from the origin through to the extinction of one of the earliest known arthropods in the Cambrian period. Okay, so just a brief overview of what I'll be discussing. Charles Darwin actually in 1886 published his Origin of a Species, naming trilobites and brachiopods amongst the oldest known animals due to the fact that no other animals had been found in the fossil record beforehand, and all varieties of marine environments in which they exhibited from, to the point of 20,000 species being existed, from the Cambrian explosion to the Permian Triassic extinction, provides it a great fossil record and biostratigraphic indicator. So today I'm hoping to leave with you the knowledge of the ancestry of the trilobite, despite its contentious background, the species divergence to a point at which 20,000 plus species did emerge, the key attributes which define the trilobite, through to the extinction and, importantly, the usefulness to paleontologists today. So this is just a brief outline of what the trilobite anatomy looked like. By definition, they had three lobes, or the axial lobe, flanked by the pleural lobes, but generally the cephalon, head region, the middle thoracic segmented region, and the pygidium or tail region define the trilobite. Other key features include the calcitic eyes, for which they were famous for, the circummolecular molting stages, of which they branched out from, and also the hypostomal wings, at which they used for feeding and floating purposes. Okay, so here's also a contentious evolutionary path of the parvum carina to the trilobite. You can see here an ontogenesis path showing the parvum carina being the common ancestor, having a single suture, and during the proapsis-merapsis stage, you can see why it could be the primitive ancestor of the trilobite, just owing to the fact that the Primicaris, Naroia, and Helmetidae all demonstrate just the eventual evolutionary path to which the truncated branches and the cephalon and pygidium region were formed. Okay, there were some other possible evolutionary paths as well, which are still being debated, like the Sprigina flanderisi, but the downward line of the truncated branches, and also in the Bombokelia kaleri, having no jointed limbs, turns us away from it being the arthropod species. Okay, so classifying the trilobite is generally done through functional morphology due to the wide variety of geographical niches. Their living relatives as well, the horseshoe crab, the crustacean family, as well as their numerous feeding habits from predator to filter feeding. And here's three examples you can see, the two earlier ones from the red loquita order, and also the Corniexoqueta, at which they were defined by their spiny bases. And the functional morphology, we can see here an example of a predatory trilobite, the Olenoides serratus. It has a smooth, broad, flat axial lobe, as well as very spiny mathobases along the underlining of the body, at which they moved benthycally along the floor to tear prey along and to ingest it that way. And also we have an example of the filter feeders with a very large cephalon head region and the collapsible hypostomal region, in which the suspended material was caught by the genal spines behind, and it would be ingested that way. And this is the Cryptolithus species. Also that we have an example of the Agnostida order, at which the blind or reduced eyes, in which case we've assumed that they were living on particle feeding, and they were living in darker conditions because of this fact. Also a very debatable order, this one. Okay, and here we have the 10 orders of the trilobite, obviously a few. We can see the origins of the red loquita order in the early Cambrian period, at which most of the orders diverged from. And we can see here that the Protida was the only trilobite to exist from the late Devonian period, and was ultimately the demise during the Permian Triassic extinction event. And you can see here just a few different examples of other animals and their evolution and extinction, mammals and trilobites disappearing 250 million years ago. So why did they disappear? Ultimately, and ironically, it was their rapid diversification which did cause their extinction, having found themselves in so many geographical niches. When the Permian Triassic event did happen, at which 90% of all species were extinct, the marine and benthic infaunal organisms in particular were irrecoverably damaged due to the fact that their food source and habitat was destroyed. Okay, so just in summary, the major role that trilobites did play in determining the order and age of geological strata, particularly during the Cambrian boundary, at which major advancements during the earliest known complex life. Also the diversity at which they displayed, again with 20,000 plus species, particularly in the Cambrian, has been vital for evolutionary biology, for paleontology and even in plate tectonics. And they continue to enlighten us in the future today. So now, just as a demonstration as to what they actually look like, I thought I'd give you an example of them moving along the benthic floor. You can see here the Olenoidus serratus moving along, lots of very small legs, searching for prey. And you can imagine it fossilising right with their hard exoskeleton here. And you can see it disappearing away into the fossil record for paleontologists to find another day. Okay, so here's my references. Thank you very much for listening, and if there's any questions, I'd be happy to help.